This is one version of a Faraday's Law Lab. Here we have Faraday going to witness the new incarnation of his lab. The equipment here is a coil which we will be producing current in, producing a varying magnetic field, which will produce magnetic flux through the small search coil of 2,000 turns. What we'll be doing is looking at the signal produced in the search coil on the oscilloscope and taking data to relate this directly to Faraday's law. So I'll step around here and point out the data taking procedure. The equipment we'll be using, in addition to the main field coil and the search coil, will be an oscilloscope, cathode ray oscilloscope. Actually, this is not a cathode ray anymore, but it's the new version. We have a resistor which will be used to develop the output signal from the search coil. That will be set to 1200 ohms. And then we have an adjustable power supply which will be providing an adjustable frequency and amplitude triangle waveform, which will be the input waveform to the field coil. Now, there are two parts to the experiment. The first part of the experiment is to see how the output EMF in the search coil developed by Faraday's law will depend on the rate of change of a current passing through the search coil. The proxy for the current in the search coil will correspond to the voltage developed across the test resistor that's in series with the search coil, and we will take data comparing that to the input parameters of the input waveform. So the way that the data will be taken is, to begin, we'll start with and remain with 500 hertz signal, or 0.5 kilohertz signal. We'll start with a 1 volt peak triangle waveform, and then on the dual trace oscilloscope we'll have two signals, one corresponding to the input waveform to the primary coil. This is varying in a linear fashion as a triangle waveform from -1 volt to +1 volt, the peak value being +1 volt. And the channel 2, which is connected to the search coil, this will be the signal developed by Faraday's law. We'll be measuring the peak-to-peak value, from which we will divide by 2 to get the peak output voltage. Now, since this is a triangle waveform with a constant rate of change, by Faraday's law, the output signal will be constant, corresponding to the constant rate of change of the input signal. We can measure directly channel 2's peak-to-peak value here, and right now with this particular position we have it set at 1 volt peak, 500 hertz input waveform. The peak-to-peak output signal is showing to be 16.0 millivolts. Dividing that by 2 to get the peak value will give us one of our data points. Then, to go through the remaining data points, we'll simply increase the signal peak-to-peak value, or rather peak value, in 1 volt increments, starting at 1, which we've already taken, and then going up in 1 volt step up to 7 volts. I'll just show what happens when we change the signal to 1 volt higher, from 1 volt peak up to 2 volts peak. Now take a notice of the blue channel 2 waveform increasing in amplitude as we increase this voltage right now. Now at this point, the voltage of the input has ranged from going from -2 volts to +2 volts, and the output signal on the secondary coil has a peak-to-peak value of 28.8 millivolts. In this fashion, we'll simply go up in 1 volt increment from 1 volt up through 7 volts, generating our data set for part 1 of the experiment. Now, for part 2 of the experiment, we're going to leave the frequency at 500 hertz. We're going to leave the peak value of the input waveform to 7 volts, And now we're going to test the dependence of the peak output voltage developed according to Faraday's law as a function of the angle between the magnetic field direction and the direction of the axis of symmetry of the search coil. We've already got one data point from that data set because here we have the search coil coaxial with the main field coil. And now what we're going to do is to increase in 15-degree increments the angle between those two axes, going over the range 15, 30, 45, 60, 75, and 90 degrees, and record the value of the peak output waveform. So let's go to the second data point now. Remember, we've already got the first one measured. Let's see, if I rotate this primary coil to make a 15-degree angle between the two coils, that would correspond to right at this point right here. And you can see the value of the secondary voltage has decreased from the starting value to a peak-to-peak value of 92 millivolts. We would divide that by 2 to get the peak output voltage and then proceed to the next angle. I'll just go ahead and show one more data point. We'll rotate this around until this is 30 degrees. And then as you see, the output voltage has decreased again, this time to a peak-to-peak value of approximately 81.6 millivolts. And we would proceed in that fashion to fill up the rest of the data table. So this concludes the data taking. The data for the entire experiment will be presented along with this film. All data required to analyze this experiment and generate a lab report have been included in the corresponding handout. This includes specifications for both coils and all voltage and frequency settings.